Hello guys, welcome back to my channel. I am Purnima R, currently pursuing in BE third sem at Sri Venkateshwara College of Engineering, and my USN is 1VE23CS 122. Today I am going to discuss about the topic called best fit, that is come under the subject called operating system, and the subject code is BCS 303. So let's move on to the topic, memory allocation techniques in best fit simulation. Memory allocation is essential for efficient use of computer resources. It determines how memory is divided among processes and applications. Today we will delve into the intricacies of one of specific techniques, that is best fit. This presentation will walk you through the fundamentals of best fit and how it's implemented in C. We will also explore its advantages, limitations, and compare it with other allocation techniques. Introduction to memory allocation. What is memory allocation? Memory allocation is the process of assigning memory to programs or processes running on a computer system. It involves dividing the available memory into smaller chunks that can be allocated to individual processes. Why it's crucial. Efficient memory allocation is essential for smooth system operation. It ensures that the process have enough memory to execute, prevents conflicts, and optimizes system performance. Understanding contiguous memory allocation. What is contiguous memory? In contiguous memory allocation, each process is assigned a single contiguous block of memory. This means that the memory assigned to a process is located in one contiguous segment. The advantages. A contiguous memory allocation is simple to implement and offers fast access times for data stored within the process's allocated memory space. Disadvantages. External fragmentation can occur as small, unused memory spaces become scattered throughout the memory, leading to inefficient use of available memory. Defining best fit algorithm. The goal is allocate memory by finding the smallest available block that can accommodate the requested size. And the process is the first one, search for the smallest free block that can fit the process. And the second one, allocate the block to the process. The third one is update the free memory list. Best fit algorithm characteristics minimizes external fragmentation. So the algorithm tries to utilize memory efficiently by minimizing the leftover space in memory blocks, less internal fragmentation. Since it aims for the smallest fit, internal fragmentation is relatively lesser than the other methods, and it can lead to collisions. When a process is freed, the algorithm may be able to merge its freed space with the adjacent blocks, further reduction of fragmentation. So this is the C program, that how the memory is allocated in the best fit algorithm. So the next is simulating memory allocation using best fit. There are 5 steps in memory allocation using best fit. So the first is initializes memory with a fixed total size, and it defines the size and start addresses of the first memory block. And the second step is implement a function to allocate memory to process by finding the best fit block and update the memory blocks. In third step, the best fits implements a function to deallocate memory for a process by freeing its allocated block and updating memory blocks. In fourth steps, the best fit simulates the allocation and deallocation process by calling the allocation and deallocation functions based on user inputs. In last step, it displays the memory layout after each allocation or deallocation, illustrating the state of memory blocks. The next is analyzing memory utilization with best fit. There are three steps. The first one is matrices, and second one is analysis, and the third one is optimization. First one is matrices. The memory fragmentation, memory utilization, and execution time can be used to analyze the effectiveness of the best fit algorithm. And the third one is analysis. The measurement and the compare memory utilization, fragmentation, and execution time of best fit against other algorithms under different workloads. And the last one is optimization. Identify areas where the algorithm can be optimized to improve memory utilization. Best fit analysis. The best fit analysis includes the review of all profiles of the match types required and calculation of the overall score compared to the source profile. The overall score appears in the overall fit column in the results section on the Find Best Fit page. Employees, managers, and HR specialists can use the best fit feature to match and compare profiles with the selected match criteria. The best fit feature finds profile that closely match the source profile, can associate job name to job profile type, position name to position profile type, and organization name to organization profile type. Best fit analysis types. The application supports the following four types of best fit analysis. Person to job. Using a person profiles as the source profile, you can find the job that best fits a worker. Example, as a manager, use this tool to help a worker to identify job profiles for which the worker is best suited and decide the next career move. Person to person. Using a person profile as the source profile, you can find the worker with skills that match that of a particular worker. Example, your company is planning to launch a new technology. As an HR specialist, you can a worker who has the required skills to use the new technology to access the scope of workers who needed development in this particular skill. You can select the worker's profile. You can then use the best fit feature to review a list of the workers who may come close to the skills requirements. Job to job. Using a job profile as the source profile, you can find a job profile that closely matches a job profile. Example, as an HR specialist, you can use this tool to help locate jobs to identify areas for outplacement, training requirement, areas of organization strength. The next is job to person. Using a job profiles as the source profile, you can find the best fit worker for a job. Example, as an HR specialist, you can use this tool to help you locate the most qualified workers for a job opening with your company. Advantages and limitations of best fit. The advantages is best fit minimizes external fragmentation and it reduces internal fragmentation and it can also improve memory utilization. And the limitations are best fit can be computationally expensive, especially large number of memory blocks, and it may still fragmentation. Comparison with other allocation techniques. So, firstly, first fit. Advantages is it is simple and fast, and it can lead to high fragmentation. The next is best fit. Best fit minimizes external fragmentation, and it may can be computationally expensive. And the third is worst fit. Worst fit can be useful for specific scenarios, and it may often leads to high fragmentation. So this is a brief overview of the best fit allocation algorithm. The operating system maintains a list of all free memory blocks available in the system. When a process requests memory, the operating system searches the list for the smallest free block of memory that is large enough to accommodate the process. If a suitable block is found, the process is allocated memory from that block. If no suitable block is found, the operating system can either wait until a suitable block becomes available or request additional memory from the system. Uh, the best fit allocation algorithm has the advantages of minimizing external fragmentation as it searches for the smallest free block memory that can accommodate a process. However, it can also lead to more internal fragmentation as processes may not use the entire memory block allocated to them. Overall, the best fit allocation algorithm can be effective way to allocate memory in an operating system, but it is important to balance the advantages and disadvantages of this approach. The other allocation algorithms such as first fit, next fit, and the worst fit. So this is all about the best fit algorithm. Thank you for watching, guys. Please do like and share the video.